Thank you. Yeah, wow, that was quite an introduction. I hope I could live up to at least some of it. So as Yasmina said, I am currently a software engineer at Test at Google. And today I want to talk about, I'm excited really to talk about architecting your JavaScript application for testability. My Twitter handle is up there, ZZOASS. Occasionally I have something intelligent to say, more often than not, maybe not so much, but feel free to follow me or email me. There's my email address, mark@zzzo.com, with questions, comments, concerns. So with that, let's just jump right in. When most people come to JavaScript, myself included, we come from a different language. I came from Perl mainly, and then before that C, C++. And when people get to JavaScript, usually they just are trying to do something quick when they first start off, and that's when things go awry. When you just try to do things quick, things that you do quick grow, and once you've sort of started off on a poor foundation, and then this thing starts growing, it becomes really hard to maintain and really hard to test. So in JavaScript, no different than any other language, it's very important that we start with sort of a solid foundation so that our code is maintainable and testable going forward, because code does continue to grow. So when we talk about testability, what do we really mean here? Well, these are sort of all the standard stuff that you've heard a lot of other people and myself say over and over again. We want loose coupling between the various pieces of our application. We want all of our methods and classes, our objects, to have a sort of a tight focus. We don't want them off and doing 10 different unrelated things. We want them doing just really one specific thing. We don't want any surprises. This includes side effects. When I call a method to do one thing, I don't want it to do 3 other things that I might not be expecting. This really makes our stuff hard to test. And then finally, especially with an eye to testing, testing can be sort of tedious, let's say, by itself enough. We don't want to do anything that adds any more tedium to test, because as programmers and just as human beings, if something is tedious, we tend not to do it, we blow it off, we don't do it as well as we should have. So if we could sort of minimize the tedium involved in testing, it makes our jobs significantly simpler. Now what's interesting here is we talk about these things and things like this, and everyone sort of agrees, yes, these are great things. We should really have loose coupling, and our methods really should be tightly focused. But we never really dig into the nitty-gritty of how exactly do we achieve that. So the sort of aim of this presentation today is to really get down and dirty, looking just directly at code, and we're going to see exactly what we need to do, or one solution that we could utilize to actually achieve these things. And it really all boils down to writing and thinking about and using interfaces, not implementations. So what I mean by this, we spend a lot of time in JavaScript and even in Java and C++ and other object-oriented languages talking about hiding things from users of our object. We're going to use the module pattern to make properties hidden and private from you. We are going to maybe use an underscore to prefix or postfix our property names to sort of mean, hey, this thing is private, don't touch it. And unfortunately, when we are thinking in those terms, we've sort of failed. And what we failed at is we failed at providing a clear interface to the users of our objects of what they should be able to touch. And when we talk about hiding things, what we've done here is we've accidentally confused implementation and interface. So specifically what I'm talking about here is when we program and think in interfaces, it makes our objects a lot easier to switch out. And I'm going to show very concrete examples of what exactly I'm talking about here. It's going to let us swap implementations very easily. And this is what gets you loosely coupled code. When you're able to swap objects in and out without the rest of your application knowing about it, you have loosely coupled code. Also, when we deal with interfaces and not implementations, it allows us to to code and test in parallel. So we don't have to wait for one group to be done with an object completely before we could write the test for it. Or we could write the test beforehand without the object already being done, because we're dealing with an interface and not with an implementation. And finally, as we'll see when we dive into the nitty-gritty here, we only have to write our tests one time. So this sort of minimizes the tedium of having to write tests over and over again. When we write and test to interfaces, as the implementations change, our tests don't have to. And we will see very explicit examples of that. So, speaking of explicit examples, let's just jump right in. When I say interfaces in JavaScript, the first reaction is, but JavaScript doesn't have interfaces. Well, it's true. JavaScript does not have a blatant interface keyword like Java does, for instance. But JavaScript being a very flexible and dynamic language, we can create an interface very easily. In fact, here's an interface right here. It's just an object, but our object essentially just consists of interface methods. And these interface methods in this interface don't actually do anything. They could just throw an error saying, hey, someone needs to implement this. But for now, it doesn't matter. Here is our JavaScript interface. So what this is an interface into a user repository. So most applications, especially JavaScript-based applications, deal with users. And you need a way to take those users and persist them off somewhere. And you don't really care where, as far as you're concerned. You just need to store a user somewhere. Eventually, then you need to get the user back. Maybe you need to edit a user or delete a user or do a more sophisticated query for a user or a set of users. But the point is here we have an interface that's going to represent our user repository. And we don't care about the implementation of this interface initially. All we care about is we have a nice, clean interface here that lets us write a test to the interface. So here's a test that's going to test the save and the get features of our interface. And you can see this function takes a repository object, and it's going to create a user, and then it's going to save the user, then it's going to get the user back, and then it's going to expect that the user I got back was the same one I just saved. And the color coding here just means the yellow represents an interface, and then the blue represents interface methods. So however this interface is actually implemented, the test doesn't care, and in fact our application shouldn't care either. We are just going to use the interface methods that are provided for us, save and get. Okay. So let's look at an actual implementation of that interface. So the implementations capture the implementation details. And in this case, the implementation detail is that I'm going to use the Redis data store to actually implement the user repo interface. So how I do it looks like this. I start with a function constructor. I'm going to create a new object called user. I'm going to define an object called user repo Redis. It has a constructor. The constructor takes implementation-specific parameters necessary to create this implementation. And in this case, for Redis, I need a host, a port, and a set of options. Then I turn around, and in the constructor, I create whatever I need specifically for this implementation to actually implement the interface. So in this case, I need to create the Redis client. Now what I do here is, for the prototype of this object, for this constructor function, I am going to set it, I'm going to use object.create of the interface. So what I'm sort of doing here is I'm announcing to the world that this user repo Redis object is going to implement the user repo interface. And then what I do is I blow through and I implement all of the interface methods on the function's prototype. So I'll have a save, I'll have a get, I'll have a query, a delete, or whatever. And then in these methods, this is where I'm going to do the implementation-specific work of actually saving the user object off to Redis. Get the user back from Redis. Okay? So now let's look at what this just bought us here. So what we have is we have an interface object that has no initialization. This is a user repo interface we looked at. There's no initialization involved with it. It's just a set of sort of empty methods. Then I have an implementation that has a constructor that takes what are called injected dependencies, and we'll talk about that a little bit more later, to do what the implementation-specific version of that interface needs to do. In our previous example, it had to create a Redis object to deal with the Redis data store. And then finally, we say, not quite finally, but then we say in the prototype, we set it to be the object.create of the interface, which sort of announces to the world that we are going to implement this interface. In this example, it's the user repo interface. And then finally, on the prototype, we override or we define all of the methods that the interface says that we, as someone who implements this interface, needs to define. So that was the save, the get, the query, the delete, etc. So what that buys us is I've already have the test for this. This is the test I wrote earlier that just spoke to the interface. And now when I want to test my user repo Redis implementation, I just create a new one of those. And then I send that off to my test method. And now my test method calls the save, calls the get, and checks to make sure that the right things happen. And you'll notice that my test method has no idea that that there's an implementation detail that I happen to be storing this stuff in Redis. Doesn't know, doesn't care, doesn't want to know, doesn't want to care. So time goes on, and my application is now getting more and more popular, and for one reason or another, Redis no longer suits my needs. Well, now I say, you know what, I really want to use Amazon S3 to store my users, or as my data store. Hey, no problem, because I am just programming to interfaces. All I need to do is I create a new implementation of my user repo interface. I'm going to call this one user repo S3. Again, this has a constructor that's specific to S3, the implementation detail that happens to be I'm using S3 as my data store. And in this case, the constructor takes a key, a secret, and a bucket. These are the parameters I need to create my Knox client, which is just a Node.js client for Amazon S3. So now I turn around and I create my S3 object in my constructor. Again, in my prototype, I announce to the world that I am going to be implementing the user repo interface. And then finally, on the prototype object, I then blow through and I implement all of those interface methods, save, get, whatever. And because my application and my tests have just been programmed to use the user repo interface and not the implementation, I could just swap out, when I'm ready, my Redis implementation for my S3 implementation, and my application is not going to know the difference. It's the same difference. And now I have a nice loosely coupled system here where I was very easily able to swap out my Redis data store implementation for my S3 data store implementation, and nobody's the wiser. And in fact, when I need to test this thing, guess what? I've already got the test written. It's the exact same test I had before. I now, instead of instantiating a user repo Redis, I now instantiate a user repo S3. I pass that to my test method. It does the exact same stuff, saves it off, gets it back. Lo and behold, it works, and I didn't have to change my test. And I didn't have to change my application either. So, that brings us to our first principle of the day, the single responsibility principle, which is something that you should be following. This helps keep our applications and our objects loosely coupled. And it says here, and you can read it as well as I can, that every interface should have a single responsibility, and that responsibility should be entirely encapsulated in the interface. So the interface here was our user repo. Everything that has to do with saving and getting users to and from a persistent data store is mentioned in the interface, and nothing extra. There's nothing in there you notice about security. There's nothing in there about caching. There's nothing in there about logging or profiling. Those are sort of orthogonal things that we will see how to add those in later. But we really want to follow this single responsibility principle that we just want to do one thing and do it well, and that one thing is encapsulated by the interface. Which brings us to our second principle of the day, which is the interface segregation principle, which is similar to the single responsibility principle, which just says no object should be forced to depend on methods it doesn't use. For instance, in my user repo interface, if I added logging or caching or security in there, there may be implementations and there may be objects that don't want to do logging, that don't want to do caching. And if I put that stuff in there, then those implementations or my application itself that relies on a user repo would be forced to have caching or logging or security, for instance, that it doesn't want. So the end result here is our first principle of the day, which I am going to call the interface pattern. Sorry, our first pattern of the day. And there's only 3 of these patterns, so don't worry. And the pattern sort of rolls us all up together. When we're creating these interfaces, what we want is we want to maintain the single responsibility principle. Something we haven't talked about yet is we want to match sets with gets. And what I mean by that is if your interface has a way to put something in, like store a user, it needs to have the corresponding way to get it back. Like I save, I need to have a get. And I really bring this up mostly in the context of, which we'll see a bit later, logging, profiling. Logging, I see lots of interfaces that it's sort of a one-way interface where there's a way for me to log a message. I could log a debug message, I could log an error message, but there's rarely a way to then get those logs back. And so what ends up happening is sort of outside of the context of your logging interface, you are scraping the file or you're monitoring the file some other way or the database, wherever you're putting your logs, to then try to extract the logs later. Put all that stuff in the same place so it could reuse the same interface and you don't have some sort of out-of-band process later on after the fact trying to scrape things. So just match your sets with your gets. And then what you end up with when you start programming your application and architecting your application in this way is you have more smaller interfaces and fewer giant interfaces. And this is a good thing on a lot of levels. One, it's a lot easier to test smaller stuff than it is bigger stuff. It's a lot easier to mock out or stub out a smaller interface than a larger interface. It's a lot easier to test in general, as we said at the beginning, more tightly focused smaller methods than a ginormous monster method that's doing, 8 things. So we want more smaller and we want fewer bigger. And then we have the interface segregation principle, which says our stuff is tightly focused. We're only going to do one thing. And then finally, as we've seen earlier, you want to test and program your application to the interfaces, not to the implementations. This lets us get loosely coupled code. We could swap out our implementations very easily without the tests or the code that relies on it knowing or caring. And this is how we get loosely coupled systems. Okay. I'm just going to take a quick look at the questions here. Okay, we'll get to some of these questions later. So you spent a lot of time designing these small, tightly focused, single responsibility principle, interface segregation principle interfaces. You've created some implementations that use them. Now how do we actually use these objects in our code? Well, I want to show you first what not to do, and then I'll show you what to do. So let's start with what not to do. So the first thing you do not want to do is, say in your user controller that actually needs a user repo, because your user controller is going to be the thing that's actually saving and getting users back. What you do not want to do is call new on your user repo Redis object within this object. Lots of reasons why you don't want to do this. The first reason is that you've now tightly coupled your user controller to your user repo Redis implementation. Problem is here is that later on, as you switch from user repo Redis to user repo S3, now you need to go through everywhere in your code where you've called new on this object, and you've got to replace it with your S3. And not only that, you're saying here in your user controller that I rely on Redis. And you don't want your user controller to rely on Redis. You want your user controller to rely on just a generic interface-based user repo, not a specific implementation of the user repo. Also, this is harder to test. Now when I want to test the user controller, I need to mock out user repo Redis itself and put that like in the global scope, and it just becomes a significant problem to test. And we'll see when we do it the right way how it will be much easier to test. So here's what you actually want to do. You want to, just like we did with the constructor function when we created specific implementations, is you want to inject the user repo object into your controller. This has a lot of nice properties, the first of which is the user controller object cannot be constructed. You can't even create one of these until you pass in its dependencies. The second one is the user controller object has no idea, doesn't want to know, shouldn't care about what the specific implementation of the user repo interface that I'm actually using is. So here in my controller constructor, I'm just saving off a copy of whatever user repo happened to be passed into me. Maybe it was the Redis one, maybe it was the S3 one, maybe it was a MySQL one, maybe it was, whatever data store it is. Maybe it's a text file-based data store. We don't know. We don't care. We don't want to know. We don't want to care. This is what gives us. This gives us our nice loose coupling. Which brings us to our third principle of the day, which is the Liskov substitution principle. And this principle is really just common sense. Its name sounds more impressive than what it actually states. But all this really says here is that any object that implements an interface can be used interchangeably. So this gets us, in our previous example, this lets us pass in a Redis implementation and S3 implementation. It doesn't matter. Our user controller is just expecting a user repo object that implements the user repo interface. Those are the only methods I'm allowed to call on that object. And as long as I stick to that contract, I have a nice, loosely coupled system. Okay. So taking sort of a half step back here, we've seen that our dependencies are quote-unquote injected, which just means passed in, to our constructor. And this is a really nice feature to have for several reasons, and those reasons, some of these reasons are listed here. One of which is what I talked about earlier. It makes our dependencies explicit. That means when I look at this object, I can't even, I could see sort of at a glance what is needed to create this object. So my user controller, I could see that I'm going to need a user repo object. For my user repo Redis, I could see at a glance all of its dependencies. They're right there in the constructor. Takes a host, a port, and a set of options. And in fact, when you start programming like this, you may have a constructor that you see is taking 6, 7, 8 parameters as dependencies or more. That's a very easy sign, a smell, if you will, that, hey, this object is maybe trying to do too much. Maybe I need to be refactoring this. This is too crazy. When you start having more than 3, 4 dependencies, that's a really clear indication to you that you're maybe trying to do too much here. Again, when you inject all of the dependencies into the constructor, this gets us this nice loose coupling that we've been talking about. This lets us swap out implementations at runtime very easily without anybody being the wiser. And then finally, you cannot instantiate one of these objects until you've passed in all of its dependencies. So one of the problems that hinders testing is sort of what's called temporal dependencies. And what that means is in order to use this object, you need to create it, then you need to call a init on it, then you passing in more stuff, then you need to do something else, and there's a sort of list of 3 or 4 things you need to do before you can get your object in an actual usable state. Well, that's problematic for testing. You need to remember to do all those things. It's problematic in your application code. You need to remember to do all those things. You forget one of those steps, you're screwed. You have hard to find bugs. This gets rid of all of that. You can't even create an object that's usable until you pass in all of its dependencies or inject all the dependencies into the constructor. And this is a great property for testability. And then this also lets us very easily inject mocks or stubs into the object when you're trying to create this, when you're trying to test this. Okay, there are a couple of exceptions to this rule of injecting all of your dependencies, and we're going to look at how to deal with that a little bit later in the presentation. But just to know, if your object has sort of runtime dependencies, you can't create it sort of up front until you know what those dependencies are. So you're sort of in a chicken or an egg situation, and we're going to see how to deal with that a little bit later. Same goes with objects that have a shorter lifetime than the object you're creating. And again, we will see how to look at that. So first maybe a yellow flag or a red flag that should pop up in your mind when I say you can't even create an object until you pass in all of your dependencies. That sort of says you're pushing the responsibility back for an object's dependencies onto the person that needs it. And that sort of seems backwards. I just want to use this object. I don't want to be on the hook for creating all of the dependencies that this object needs before I could use it. That doesn't seem to make sense. Shouldn't that object be encapsulating its dependencies for me? Well, you're right. You should not have to create an object and know all of that object's dependencies, before you can use it. In fact, you should not even be creating objects at all, which is what I sort of was alluding to earlier when I showed you how not to do things, and I said do not call new within your constructor. This stuff should be injected in. It's not up to you to create these objects. What I want to say here and what I want to press upon you is there's really 2 stages to your application. There's the very beginning, when your application starts, and at the very beginning, right before your application starts, you create all the objects you're going to need during the lifetime of the application. And then once you've created everything, now you sort of kick off your application, and now you use all those objects that were sort of pre-created for you, and off your application goes and does all of the things it's supposed to do. So when you create all of the objects you're going to need at the very beginning, that gets you nice, loosely coupled code, such that later on, when you switch from your Redis implementation to your S3 implementation, you just, at the very beginning, instead of creating a user repo Redis object, you create a user repo S3 object and inject that into all the dependencies, and then off your application goes up and running. Well, your first question is, okay, that sounds amusing, but how exactly does that work? Well, at the beginning of your application or during the request cycle is something called the composition root. And all the composition root is the place where you are going to create all the objects that your application is going to need during its lifetime. And typically the composition root happens at application startup. For web applications, there's another composition root, which is during the request cycle. For instance, you don't know who the user is until the request comes in, and you look at the session key, and then you can create the user object that request is going to use. Then once you've created that sort of user object, then it could be used for the rest of the request cycle. So you sort of have, and there could be more than one composition root, but the typical ones are when the application first starts, you're going to create, like, say, your user repo object, and then during the request cycle, you will create request-specific objects that just last for the lifetime of the request itself. And then that is separate from the actual use. Once these objects are all created, you can then actually use them. Well, that all sounds amusing, but what the heck is creating all the objects? So this is where your dependency injector or your inversion of control container comes to the fore here. What happens is you define all of your relationships up front, all your dependency graph up front, and then your dependency injector or your inversion of control container or whatever the heck you want to call it, then blows through your object graph and then creates all this stuff. So you sort of say, A depends on B, user controller depends on the user repo, and then user repo depends on a host port and an options, and then a host is just a string. So eventually you get to the point where you have an object that has no dependencies or just sort of primitive dependencies. You create those, which then allows you to create the next higher one, and then the next higher one, and then the dependency injector works all the way up your object graph till it gets to the very top, which is sort of the top level object in your application, and then once that's created, it sort of kicks off, start, go, and now your application has all of these objects created for it from the beginning, and then your application can now run. Now in JavaScript, we have several different inversion of control containers you could use, or dependency injectors. Wire.js is probably the most popular. AngularJS also does this. You can also do it-yourself dependency injection. If your application isn't that complicated and you're only creating, say 5 or 10 objects at the beginning, you could just wire them all up yourself and then pass them to your highest level sort of application object and then call go, and then you're off and running. Okay, so I alluded to this stuff earlier. We're going to jump back into code here and see specifics of this. I alluded to this earlier. I said we want to have tightly focused, small, single responsibility, interface segregation principle interfaces that just do one thing and that's it. So then the question becomes, well, there's some things I might want to do, or some of my objects might want to do. How do I embed those into the fabric of my application here? So these are these cross-cutting concerns that we hear all about. This is the logging, the auditing, profiling, security, and caching. You don't want to bake those into your implementations because you may or may not want to use logging. You may or may not want to use caching. How could we weave these into the fabric of our application? So let's take a look at this. So again, we're going to start with what we do not want to do. And what we do not want to do, for reasons we saw earlier, is in our user repo Redis implementation, we do not want to sort of burden it with logging and profiling. So in this example here, we want to add logging and profiling to our user repo objects. And again, and we've seen this before, we don't want to tightly couple ourselves to logging and profiling because there could be pieces of our application that want to use user repo Redis but don't want logging and don't want profiling, and they shouldn't be forced to have them. Again, this is a pain in the butt to test when we sort of bury these, these objects within our implementation. So we know we don't want to do that. So your next thought might be, well, okay, let's inject them via the constructor, a logging and a profiler, into the user repo Redis constructor. This is on the right path, but this is not what we want to do either. And this is, again, because now anyone who wants to use the user repo Redis object, whenever we instantiate this thing, now in order to create it, we have to pass in a logger, we have to pass in a profiler, and we may not want logging and profiling all the time whenever we use user repo Redis. So it looks good, but it's not quite there. And the reason why it's not quite there is because what you would end up with then in your save method is embedded in the specific implementation of user repo Redis. Now I'm calling logging, now I'm calling profiling, and then buried within that I actually do the saving into the Redis. And the problem is that every time I use user repo Redis, now I have to have logging and I have to have profiling, and it's sort of stuck in there. And not only that, when I switch over to my user repo S3 implementation and I want logging and profiling there, now I've got to remember, and I've got to cut and paste this code and move it over to my S3, and now it's stuck in my S3 implementation. So we don't want it there either. So what we want to do with these cross-cutting concerns is we want to keep the different functionality separate. This makes testing much easier, makes us not be forced to use logging and profiling everywhere I want to use user repo Redis. And I don't want to violate the interface segregation principle, which says if I don't want to have to depend on functionality I might not need, in this case the logging and the profile. Okay, so how are we going to solve this? What are we going to do? Well, here's what we're going to do. Okay, let me try that again. Like most things, the answer lies in using interfaces and not implementations. So let's look at a quick logger interface. Here it is. It only does two things. It's going to log a message, and then as I stated earlier in the interface pattern, if I have a way to put something in, I want to have a way to also get it back out. So here I'm going to call a log to put something in, and then I'll have a get last log method to get the thing back out. Let's look at a simple implementation of this interface. Again, I have, just like my previous one, I have an implementation specific constructor. Here, this one is going to log to a file. So I'm going to take the file in the constructor. I'm going to announce to the world that I am going to implement the logger interface for this object. And then finally, I'm going to blow through and override all the interface methods on the prototype. Here's the log one. I didn't have room on the slide for get last log, but you can imagine what that one looks like. And what's interesting here is that this one implements the logging interface. I so happen to be logging to a file. Later on, I decide that was no good, and now I want to log to a database. No problem. I create a logger MySQL implementation of the logger interface that will just follow the interface methods, and I could replace it later on in my application. And my application is none the wiser, and now I'm logging to MySQL instead of a file, or wherever else, or a remote logging system or whatever. Okay, I want to take a quick detour, a quick one-slide detour here just to look in this mix-in method, and this is going to become important for what we're about to do here on the next slide, when your minds will be blown, I promise. So JavaScript is great for its very dynamic nature. What this mixin method does is exactly what it says. It's going to take a base object and a sort of an extended object, and it's going to take all of the methods that are in the base object and copy them over into the extent to make it an extension of it in the extend.me object. And it's a very simple method. I'm just going to check to make sure that the function doesn't already exist in the base, and it is, and the property is itself a function. And if so, I'm just going to copy it over. I'm going to use bind here to make sure that this is set properly to the base method. And now let's see how we're actually going to use this thing. Okay, so we have our logger. Now what do we do? So what we want to do is create something called a decorator. And the decorator is going to mix together these two interfaces, sort of without them knowing about it. So I'm going to create a user repo logger constructor function. And this user repo logger object is going to actually implement the user repo interface. And the way it's going to do that is by using this mixin method. So let's take a look at this. The constructor function takes two things. It takes a repo, a user repo object. We don't care which one because we're just programming to interfaces. And it's going to take a logger object. And again, we don't care which one. Doesn't matter. And then what it does is instead of calling object.create on user repo, what it's going to do is it's going to mix in all of the methods from the repo object we passed in into this object. So this is really sort of a convenience for us that lets us implement the user repo interface by just sort of using all of the methods from the repo that was passed in. And where this gets interesting is now when we blow through and we need to implement all of the interface methods, well, we don't need to implement them all because we did that already using the mixin method here, is in our save method for user repo, what we're going to do is we are going to sort of decorate the save method with a call to the logger. So now I'm going to get my logging involved here. And then I'm going to delegate the actual saving of this thing to my inner repo, whatever was passed into me. So in this sense, what I've done here is I've created a new object that's a user repo object, and due to our good friend the Liskov substitution principle says, since this object implements the user repo interface, I could use this anywhere I was using a user repo before. And what's interesting here is now when I call save, I'm going to get logging, and then I'm also going to get save somewhere. And I haven't sort of conflated, my specific implementation of user repo, whether it was the Redis one or the S3 one, we don't care, with logging. So let's see what this looks like. Now I'm going to actually create one of these monsters. And I'm just going to call it user repo. I'm going to create a new user repo logger. And for grins, I'm going to pass in a user repo Redis. And I didn't show the constructor parameters here, but you can imagine them. And then for grins, I'm also going to create a logger file. And it so happens it's a logger file. It could be my logger MySQL. It could be my logger remote logging object. But the end result of this thing is a user repo object that, because of the Liskov substitution principle, I could use anywhere else I was using a user repo object before, and now I'm going to sort of get the logging for free. Okay, now let's go through that same thing again with profiling, because remember, we wanted to get a user repo object that had logging and profiling. So again, I'm going to have a profiler interface. It has a start and a stop method, and then again, since I have a way to put things in, I want a way to get things out using getProfile. And then here's an implementation of it. This one is going to profile based on time. So again, I have my implementation-specific constructor. I'm going to announce to the world that I am going to implement the profiler interface, and then I'm going to blow through all the interface methods and implement them, their start, their stop. And you can see this one is profiling based on time. You can imagine a profiling based on CPU usage, profiling based on disk usage, memory. You could have lots of different implementations of profiling. Great, no problem. They just need to implement the interface. And then I'm going to create another decorator. This one is going to be user repo profiler. And just like the previous one, its constructor takes an inner repo. We don't care what the implementation of the repo is. It's going to take a profiler. Again, we don't care what the implementation of the profiler is. Now I'm going to mix in whatever repo was passed into me, all of its methods, into this object. Again, this lets us, as a convenience method, so we don't have to implement all of the user repo methods. The ones we don't implement, we just sort of hand off to the inner repo object for it to deal with. And then for the ones that I do want to implement, I want to decorate the save here. And now my save method is going to call profiler start. It's going to hand off the saving to whatever inner repo was passed into me. And then I'm going to stop the profiling at the end. So what I've got here is a user repo object, something that implements the user repo interface, so can be used anywhere any other user repo can be used. But now I've got profiling baked in here, and not once have I sort of, dirtied the code of any of my user repo implementations with this profiling stuff. Okay, so now let's see what this all looks like. Let's put it all together here. Again, I'm trying to get a user repo object that does profiling and logging without sort of sullying any specific implementation of user repo. So in this case, I'm going to create a user repo Redis object. I'm going to create a profiler object. You can see it doesn't matter whether I create a Redis one or an S3 one. Doesn't matter whether I create a time one or a memory one or a disk space one. Doesn't matter for the logger whether I create a file one, a MySQL one, a remote logging one, whatever, doesn't matter. I'm just going to be programming to the interface. So first I'm going to create a user repo profiler object. So here I'm just going to call new user repo profiler, and I'm going to pass in the Redis and the profiler. So now I have an object that, as far as the rest of my application code is concerned, is just a user repo object. And now I want to add logging on top of the profiling. So now I'm going to call a user repo logger. And now to pass in for my user repo object, since I'm just programming to interfaces, I'm going to pass in the user repo prof object I just created, which does the profiling. And I'm going to pass in a logger. In this case, it's the file logger. And what I end up with here is a user repo object that can be used anywhere else a user repo object can be used via the Liskov substitution principle, but this one has logging and profiling and user repoing all mixed together in one object, and I haven't, and the user, the repo S3 or the repo Redis object has no idea that there's logging going on, doesn't know, doesn't care, doesn't know there's profiling going on, logging doesn't know profiling is going on, profiling doesn't know logging is going on. They're all loosely coupled and blissfully unaware of each other, and I haven't baked in logging or profiling into any of my user repo implementations. So if I want to use a user repo object without logging and profiling, no problem. I want just logging, great. I want just profiling, fine. I want them both, fine. What about if you want profiling, you want to profile time, disk space, and CPU? No problem. You just keep adding on here to your user repo object using decorators, and then at the end of the day, you finally end up with one that has maybe 10 pieces of functionality built into it, all blissfully unaware of each other, and your object can be used anywhere you are using a user repo object. Great. Okay. Cross-cutting concerns. That's how you deal with them. And then testing this stuff. Couple different ways to go about testing. We said that we've created a user repo object that implements the user repo interface, obviously. So we could just turn around and use the same test method that we already wrote for user repo objects. The only difference here is if you want to test the logging, you just create a mocked version of the logger. You create your user repo logger thing, object, and then you call you call save, or you call your test with it, and then you just verify that your logger mock actually logged what you thought it was going to log. Easy. Another way to test your decorators is you could sort of, if you want to create the full object, you just mock out all the pieces you want to mock out, and then you call that test repo method that we saw earlier, and then you just go ahead and verify all your mocks were called like you thought they were. Very easy here. I'm just reusing the test code I already wrote to test this stuff. Which brings us to our second pattern of the day, the decorator pattern. What it is, what we just saw, you have a constructor that accepts the inner, quote-unquote, inner object of the same type and any other dependencies, specifically how you're going to do what you want to decorate them with. You mix in with the inner object to get default behavior for all the non-decorated methods. This way I don't need to implement all of those methods of the interface because I'm just going to delegate them to the inner object directly. And then finally, you decorate the methods that you do want to decorate to add the logging or the profiling or the whatever else. You decorate those methods, and then you would then optionally delegate to the inner object. And I say optionally here because, say, if you want a caching system built around this stuff, you write a caching decorator, and when you call, say, get on your user repo, the cache would look in its cache to see if it has it. If it has it, it doesn't even need to bother to delegate to the inner repo. It could just return the user object directly. So very flexible, very loosely coupled, easy to test. This is how you want to deal with the cross-cutting concerns. Okay. One more bit I want to talk about here before I set you loose onto the world, and that is what I talked about earlier is how do you deal with these sort of runtime or short-lived dependencies. In my example here is I have a dating website. It is awesome. I want to let the user pick how to find matches that are relevant to him. And the user, say, has three choices. He could choose matches that are closest to him in distance. He could choose matches based on they have shared activities together, maybe they like to run, or he could pick based on likes, like your set of likes, are they the same? And the kicker here is that the user, while he's looking at your web page, maybe he has a pull down, he gets to pick, what matches he wants based on one of those three criteria. And the idea is, since you don't know beforehand what he's going to pick, you don't know how to set up your dependency chain. So the answer to this, as the answer hopefully is to most questions, is first we need interfaces. So our interface here is we're going to have a find matches interface. And then we're going to have several implementations of this interface, one that's based on distance, one that's based on activities, one that's based on likes. And since we don't know which one the user is going to pick beforehand, we're not sure what exactly to inject for our dependency. So let's look at this. Again, this is your standard constructor. We are going to pass in implementation-specific details to find stuff by distance. In this case, it's a user repo. Again, via the prototype, we're going to announce to the world that we are going to implement the find matches interface. And then we're going to implement that matches method. And then we're going to do the same thing for these three other matching algorithms. Okay, so here's what I was talking about in our user controller. We want to inject one of these find matches strategies or algorithms into our user controller that's going to deal with returning the user his matches. But the problem is we don't know which one to use, right? The user is going to dynamically choose, and since we can't read his mind quite yet, we have a problem. Should we inject all three? Well, that's sort of ugly. What happens if you come up with a fourth or fifth or sixth way to find matches? Then we start having a very unwieldy looking constructor. What if there's other parts of your application that want sort of dynamically injected find match implementations? So what do we do? What do we do? Well, the answer here is something called an abstract factory. Now, your head may be hurting thinking, this is JavaScript, abstract factory, why do I need that? That's insane. Well, when I say abstract factory, all I mean is an abstract factory takes a runtime value and returns a dependency. That's it. So in order to implement an abstract factory, what I'm going to do, as what hopefully by now will resonate with you, is I'm going to make an interface. It's going to be called a find match factory, and it has one method called getMatchImplementation, and you can see that that method takes a type, which is the runtime type, and then I'm going to return the dependency. So here the type is like a string, like he chose activities. So the string is going to be activity. I want to transmorgify that activity string to my find matches activities object that implements the getMatches interface, and then I can call getMatches on to get the actual matches. Okay, so let's look at the implementation of this thing. By now, this should look very familiar to you. We're going to have an implementation. It's going to take a specific, its constructor is going to take something specific that it needs, in this case a user repo. Then I'm going to announce to the world that I'm going to implement the find match factory interface. And then for the implementation on the prototype of the getMatchImplementation object method, you'll see here I'm doing something slightly strange. Again, I am taking the runtime value, which is in this case is a string, likes, distance, activities, and I'm going to return to it a dependency. And your head should sort of hurt here when you see this new here, because you should be saying, oh, what? I can't call new. That's not cool. You're not supposed to do that. Well, it turns out abstract factories are the one place where you are allowed to call new, because that's its job. Now, there is another way to implement abstract factory if you do not like calling new here. Up to you. You can, in the constructor for the abstract factory, pass in the three implementations. That's legit. And then when you, and this each case statement, instead of returning a new, you just return the thing that was passed in. That's fine. It's really the same difference. However you like to think of it, up to you. So my getMatch implementation is just going to convert a runtime value, in this case a string, to an object. And yeah, sorry, I'm running a little long here, but I promise I'm almost done. So now let's look at how we actually use one of these monsters. So here's my user controller constructor. Instead of passing in the find match dependency, since I don't know what that dependency is, I pass in the abstract factory instead. The abstract factory, I can create at composition root or at application start time or at request start time. That I can create. So I stash a copy of that. Here I announce to the world that I am implementing the controller interface. And now in this find matches method, say this gets called when the user clicks, find matches after he's pulled down the pull down to say what kind of matches he wants. Now what I'm going to do here is I'm going to use the abstract factory. I'm going to call the getMatchImplementation interface method. I'm going to pass in the type, the runtime value I just got to the user, and that's going to return to me the implementation of the find matches algorithm that I need. And now I can call findMatcher.matches, which is the interface method. For that interface, it actually returns the matches, pass in the user ID, which I've got, and now this thing can return to me the set of user matches that were determined via runtime. Okay, abstract factories are really easy to test, which is a great thing about them. There's two ways to test them. One, you test it itself. Very simple. You just blow through all of the runtime values it expects, and then in your test, you just make sure you are getting the right thing back. Really simple. So for instance, if I pass in the likes string, I expect to get find matches likes implementation back. So really drop dead simple to test. And what's great about these is when you're testing the dependency that needs it, they're really easy to mock out. Super simple. Here's a mocked implementation of the abstract factory. Again, I'm just programming to the interface. I've got my constructor-specific parameters. I am announcing to the world that I'm going to implement the find match factory, and now I can mock out the get match implementation. Very simple. I just created one knowing what type I was supposed to expect. I make sure I got that type, and I'm off and running. So really easy to test with these things. Which brings us to our final pattern of the day, the abstract factory pattern. So again, this is all an abstract factory is it just takes a runtime value and converts it to a dependency. The factory implementation gets created at composition root along with all the other objects. Then that bad boy gets injected into the constructor function of the object that needs a runtime dependency. And then at runtime, that object uses the factory, passes in the runtime value, and then gets its dependency back that it needs to do its work. Okay, and let's look at it again because it's awesome. Anyway. Okay, so to sort of wrap all this stuff up here, sorry I ran a little bit long. Testable JavaScript is really about composition, not inheritance. As we saw using the mix-in pattern and the decorator pattern, composition doesn't lock us into a specific implementation. We can slice and dice these very small targeted objects really easily to combine them, which gets us this nice loose coupling that we're all excited about. We program and we test to the interfaces. The interface is the API. Obviously, you know, when I talked about at the beginning, when we talk about hiding and using the module pattern and private variables and all that stuff, when we find ourselves doing that, what your thought should be, I've mixed up implementation and interface at that point. And if I need to hide stuff, then I've got a problem. I don't have a clean interface. I need to pull out and show up front, here's my nice clean interface. Testers can go test to it. Programmers can go program to it. And what implementation you get, you don't know, you don't care. You're only referencing stuff in the interface. Again, we want to create lots of these small single responsibility interfaces. This lets us, using the decorator pattern, mix and match them very easily without mucking them all up together. We want to decorate and intercept all of these cross-cutting concerns. We want to constructor inject all dependencies. This makes it very obvious up front what all the dependencies for this object are. It lets us mock things out very easily when we need to do tests. We just pass in mocked-in versions, real simple. And then finally, we want to inject abstract factories into constructors for runtime dependencies. Okay, last slide here, I promise. At the end of the day, there's really only one way to absolutely ensure you have testability, and that is to write the test first. And when you have interfaces, it makes things a lot simpler and a lot easier. There's my book, Testable JavaScript. I believe it's on special today, even if you want to learn even more. There's a lot more in there than what I was able to cover today. That's all I've got. I'm going to look through these questions really quickly. Sorry, I ran a little long. So one of the questions here is, do we write tests for the implementation as well? Hopefully that was answered no. No, you do not. You only write tests to the interface. Even unit tests should just be to the interface. That's all you care about is the public interface. I do not believe you should write tests for specific implementations. Okay, let's see. Which browser is better for testing or debugging? Firefox versus Chrome. Until very recently, I would have said Chrome, hands down for sure. Although the latest versions of Firefox have really started to catch up with the debugging. I personally use Chrome, not just because I work for Google and Chrome is awesome, but Chrome is awesome, and I'd say Firefox is close to being there. So it's really up to you, but I'm a Chrome guy myself. Okay, encapsulation versus composition versus inheritance. These words are sort of loaded, encapsulation especially. I like to think of things more of inheritance versus composition. In inheritance, when you start getting trees of inherited objects, JavaScript and any language, in fact, it starts getting really brittle. And the problem when you have sort of inheritance tree versus a composition tree, I mean, it's okay to use inheritance, but inheritance has a way of sneaking in implementation-specific stuff, which your subclasses may or may not need. I find it's a lot easier to just compose them using mix-ins and decorators than it is with inheritance. Most popular JavaScript test frameworks. The testing framework really can depend on which JavaScript library you've bought into. For instance, if you've bought into YUI, then most likely you're going to use YUITest. If you've bought into jQuery, most likely you're going to use QUnit. Now, outside of those, I'm a big fan of Jasmine. I tend to use Jasmine a lot. If you've bought into Angular, Angular has its own sort of Jasmine-esque based test built into it. So when you're picking a framework to use, keep in mind that you're also picking sort of the test strategy that framework wants you to use. Now, not all JavaScript frameworks, only the biggest ones have sort of a testing piece also. Outside of those, I'd say Jasmine is probably the most popular one. I'm a big fan of Jasmine. I think Jasmine works real great. In terms of, and last question here I'll take is there a way to code JavaScript that helps or hurts Selenium? So when you get to Selenium or Casper.js, or when you start testing in a browser for these sort of integration-y type tests, again, I still think the best way to code is using composition, even though when you're testing at that level, at that point you've sort of risen above how your application is put together. But I will say this, if you have a lot of small pieces, are a lot easier to test than giant hunks. So in terms of when you're creating a method that Selenium is going to hit, I would much rather that to be small and lean than big and fat. And again, I think using composition gets you there. Okay, Jasmine, that's everybody. That's all I got. I want to thank you guys very much for joining. I hope this was interesting and informative. Again, email me, follow me on Twitter. I occasionally will say something humorous or humorously ignorant, so it's maybe worth it just for that. Email me. Check out the book. Jasmine, I'm done if you want to finish it up.
Great. Mark, thank you so much for a really terrific presentation, for sharing all your knowledge and expertise with us. Folks that attended today, we thank you so much for attending our event. And for those of you that sent in your questions, a big thank you to you for that, because having those questions just adds so much more to our events. Folks, we would like to let you all know Mark's book, Testable JavaScript, is the O'Reilly deal of the day. So if you like what you heard today and what Mark talked to you about, please, we do encourage you and invite you to take advantage of a discount code that we pushed out to you all to save you some money today on the book. You can also visit O'Reilly.com. Look on the right-hand side. You can't miss it. It's right there. One more announcement, folks. Our Fluent Conference, O'Reilly's Fluent Conference, is this month, May 28th through the 30th in San Francisco. We also pushed out a code to save you some money. We still have some tickets left, and we would like to see you all if you can make it to our conference. Use code Webcast13 to save on your registration. Again, we pushed that out in the group chat as well. Mark, thank you again. Folks that attended, we thank you, and we look forward to seeing you at our next event. This will conclude today's webcast. Goodbye, everybody.